Silicon-on-insulator is a fascinating technology for ultra-dense integrated circuits. It is the practice of placing a thin layer of silicon on top of an insulating material in order to speed up the performance of a microprocessor by reducing the capacitance of the transistors and making them operate faster. AMD Tiron 64X2 is using this technology. Silicon-on-insulator technology was initially developed by IBM. The technique uses pure crystal silicon and silicon oxide to produce integrated circuits and also microchips. SOI microchips are perfect for mobile devices. Their power consumption is reduced, but their processing speed is faster compared to the CMOS-based chips. Besides that, SOI microchips also have the ability to reduce the soft error rate. Unlike the CMOS-based microchips, SOI microchips are not doped with any kind of impurities. This allows the SOI microchips to operate at a faster rate and cooler. Other than that, the SOI technology-based microchips also reduce parasitic capacitance and are also impossible to latch. In addition, SOI microchips are relatively small compared to the typical CMOS microchips. SOI microchips also edge CMOS microchips in terms of simplicity, and it supports high system reliability by allowing powered down redundant parts, which is very important today. First, there is the heteroepitaxial technique. In the technique, SOI films are obtained by epitaxially growing a silicon layer on a single crystal insulator. Silicon on sapphire source technique, which is shown in the next picture, is the most mature of all types of heteroepitaxial technique. Next, we have the homoepitaxial technique. Epitaxial lateral overgrowth method consists of growing a single crystal silicon film from the substrate. The next picture shows the application of epitaxial lateral overgrowth technique. And then we have the recrystallization technique, where most transistors can be fabricated on large grain polysilicon deposited on oxidized silicon substrate. Other than that, we have the FIPOS, which is also the full isolation by oxidized porous silicon anodic reaction, is used to convert a particular region of the silicon wafer into porous silicon. Besides that, there is the CMOX technique that involves direct injection of the purified oxygen into the silicon wafer at a very high temperature to bond oxygen with silicon to show that thin layers of silicon oxide can be formed. The next diagram shows the CMOX technique procedure. In June 2006, Freescale Semiconductor Incorporated showed the world a new CMOS technology that exploits the use of strained silicon-on-insulator SSOI substrates. This new technology is a breakthrough that could trigger an earlier release of next-generation semiconductor devices. This is the end of the presentation. Thank you. Devices.